All right, here we are with 15.2 today, multiple populations and inferences. Take a look at part one, show you some examples from here. Um, Again, this is basically going to allow you to predict or identify various populations and maybe predict how many are in each. They're going to start things off, though, with looking at one population. So if I analyze a group of people, and in this case, how many students in the school play a sport, you're looking at the whole school as one population. And if you're looking at the whole school as one population, then that's where your count's going to come from. Two populations, okay? In this particular situation, hey, who are the kids who play sports? Are they generally taller than kids who don't play sports or not? So in essence, you're breaking up the whole group now into two populations, and those two top populations are kids who play sports and kids who don't play sports. And therefore, then you're going to compare who's taller, one group or the other. Multiple populations, we look at it and say how many students play sport in each grade level, and here at Bath that would mean 6th grade, 7th grade, 8th grade, and so we'd obviously break up, hey, here's all the 6th grade kids, here's all the 7th grade kids, and here's all the 8th grade kids. How many students play a sport in the 6th grade? Get a count for that. How many kids play sports in the 7th grade? Get a count for that. How many kids play sports in the 8th grade? We get a head count for that, and then compare the three. So 3 there. Teacher gave tests to 3 math classes, and we want to know whether she should consider the classes as 3 populations or as 1 population. So you really only have 2 choices, 3 or 1. So when I talk about what was the highest score, key phrase here, overall, we're basically saying, hey, who had the highest score or what was the highest score? We're looking at everybody as just one entire population. What was the top scoring class? Now we're looking at it from a 6th grade, 7th grade, 8th grade perspective, or better yet, for us, maybe my 1st period class, my 4th period class, and my 8th period class. Then we're comparing the 3 classes to see which one was the top scoring class. What is the mean score in each class? Again, as soon as it says in each class, we're looking at 3 populations. Who's the top scoring student in each class? Once again, we're looking at 3 populations there. What is the mean score of, again, key phrase here, all the students? So that means we're only looking at the group as one. And then how does the range of the scores compare among the classes? If we're looking for a range of the scores among the classes, we have to compare all 3 of those to compare the data. All right? So there's your first example from part 1. Take a look at our next one, and again, this is going to be very similar. We're testing the eyesight of our group here at Bath, 6th, 7th, and 8th graders. How many kids have perfect vision in the entire school? And so we're looking at it, the entire school is just one population. What is the mean eyesight score for? Here you go, each grade. So I've got to take, hey, 6th grade is this, 7th grade is this, 8th grade is this. We're looking at it then from a 3 populations. Do students' eyesights change between 6th and 7th and 7th and 8th? And again, this is a little misleading because it appears as though there's only 2, but really we need data from 6th grade, we need data from 7th grade, and we need data from the 8th grade. So that's why your final answer there is going to be 3 populations. All right, last slide in part 1, and really all this is going to do is be an informative slide, it appears. It is simply saying, hey, why can we take one population in a study and consider it to be more than one population in another study? So why is it 1 in one and 3 in another, or something to that effect? And so as it states there, I'll let you read through there. We can focus on the entire population, or we could focus on a larger population in order for comparison purposes. Okay, moving on to part 2. Part 2. Again, I think there's only 2 pieces to this. And a little video clip here, which is, I know you guys don't like these video clips, but.
Here in Maine.
With my family in Philadelphia.
Came to Chicago.
3rd generation in Los Angeles.
Grew up here in Hawaii.
All right, so you can see that what they want us to do is we're analyzing census data, which obviously it's here in 2020, and we want to know how many populations we be using. So if I take a look at this first one and I say, hey, more people live in Maine or Hawaii, we're really only comparing 2 states, so it should be easy for you to determine we're looking at 2 populations. If I'm looking at the second question, we're comparing Chi-Town, LA, and Philly. So number of populations we're comparing, 3. Age of the oldest U.S. citizen. So in that situation, we're looking at all the citizens of the U.S. as 1 population. And then here on this last one, what percent of each state's population. So obviously you have to know how many states are in America. And so we're looking at 50 different populations there in order to answer that particular question. So again, this aspect of it shouldn't be super difficult for you, one wouldn't think. Okay, moving on to next round. This one you can find in your student companion book if you have that. How many species of sea urchins exist? All right, so we're looking at the sea urchin population as a whole or as one. Which continent has the greatest population? So we have to know how many continents there are. If you recall, there are 7. And then last but not least in this one, they're basically comparing sea urchins, the population of sea urchins in the Atlantic versus the Pacific. So you're really only looking at 2 populations there. Okay? So again, that should have been the easiest piece of this to decipher. We're moving here to, I'm going to go ahead and go to key concept. And then on part 3, I'm actually going to, there's not a whole lot there that I can show you clearly. So I'm actually going to dig into the homework, and we're going to pull 2 questions from the homework that are part 3 kind of questions. I think that will clarify things for you a little bit better. And obviously you could use that then in order to answer those 2 questions on your homework. If we're talking about inferences, okay, talking about inferences, and inferences when you make a judgment by looking at some data, okay? An educated guess, this would be comparable to an educated guess in science class, I would say. So in this particular situation, if I look at this, based upon sample A, 65% of the population A loves to sing, and based upon sample B, they're saying 30% of the population loves to sing. So if I use that as my inferences, and then I use those to compare, if I compare them, then obviously it compares 2, 3, 4 different things. And so as you can see here, we're simply saying that, oh, okay, well, sample A has a higher percentage of people who love to sing than population B does, right? If we take a look at part 3 then, and as I told you, I'm going to skip part 3 and I'm actually going to go to part 3 homework type questions. So here we go. I'm going to go to your homework for this evening. It's 15.2, and on 15.2, I'm going to go straight to, I've told you guys this before, that question 5 and 6 will come to you from part 3 all the time. Make that maybe a tick bigger so we can see it. All right, so here we go. So we have dot plots, all right? And so in these dot plots, we are simply describing the variability of the samples. Now remember, the variability is basically the change of the samples, all right? Are they tight together, which means there's not much change, or are they spread apart, so that means there's more change or more variability. So as you can just take a glance at this grouping, if I look at Lake R, we have some fish that are 21 ounces, and the smallest fish is 11 ounces. So what we're saying here is that the spread, or the variability there, is approximately 10 ounces. If we take a look at this one down here, Lake S, we're at 21 to 15, and 21-15 means there's a variability of 6, right? So this is more concentrated in Lake S. They are closer together in Lake S, and they are farther apart in Lake R. So in Lake R, we have more variability is what we're saying. So go over here to our multiple choice. The variability in the lakes are about the same. That's not the case. The variability of the weights in Lake S are greater. That's not true. So C must be your answer. The variability of the weights of Lake R are greater, and that basically means, as I said, farther apart. Let's go ahead and check that, see if we're good to go. We are. Let's move on to part 2 of this question then. And on part 2, they're going to basically say, all right, what does this exactly mean? Well, as we've talked about, this simply means that if I look at A, there's about the same difference in weight between small and large fish. Not true. In part B, or answer B, there's less difference in weight between small and large fish in Lake S. So there's less difference in fish size. That's our answer, because again, less difference in weight means they're closer together. So that's our answer. Move on to my next question. And then my next question, number 6, this one's probably a little bit more up your alley, talking about tree heights, okay? And it asks us to find the median. Now, median, remember, is middle number. So I could go to, for example, neighbor X's house. And in neighbor X's house, we have to find that answer first anyways. You can see I'm going to basically start clipping off the ends, as we've talked about with median. So I'm going to get rid of a 10 on the low end, get rid of a 30 on the high end. Get rid of a 10 on the low end, get rid of a 30 on the high end. Get rid of another 10, get rid of a 20. Well, that leaves us with nothing but 20-foot shadows. So obviously your median here has to be 20 feet. So I'm going to go ahead and pop in 20 as the median of those tree shadows. Good there. Now we're going to move on to neighbor Y. As I move on to neighbor Y, I'm going to do the same thing. I'm going to cross off my 30 on the low end, a 60 on the high end, a 40 on the low end, a 60 on the high end, a 40 on the low end, a 60 on the high end, and so that leaves us with nothing but 50s. And so in this particular case, this would be 50 feet. Now, I have seen an example or a problem where you might run into a situation where the two middle numbers you have left are 20 and 30. If that's the case, remember, you got to find the average of 20 and 30, so it would have been 25. So what does this exactly mean? It should tell you that, obviously, because the median of neighbor Y's tree shadows are much longer, that person has taller trees and or older trees. So person Y, you can find the one here where person Y has older trees. Most pine trees in person Y are older than, so it looks like it's going to be C. Answer the question, boom, we're good to go. Right? Well, hopefully that clears anything up on 15.2. Again, feel free to email me if you have any further questions. But for now, adios.